Okay, lesson 9.3 is the probability of compound events. And to get this lesson started, we're going to do a little shopping. So, Jake owns 3 shirts and 2 pairs of pants. How many different outfit possibilities does he have? So, we need to go looking in his closet and play fashionista. So, he could wear a K-State shirt with his jeans. He could wear his K-State shirt with his athletic shorts. He could wear his KU shirt with jeans. He could wear his KU shirt with athletic shorts. He could wear his MU shirt. I don't know why he would want to, but he could. With jeans. And then he could wear his MU shirt with athletic shorts. So, how many different outfits do we have? We have 6 different outfits. The way we get this is there are 3 possibilities for shirts and 2 possibilities for pants. So here are the shirts. Here are the 2 for pants. So you take 3 times 2 and you get 6. So that's mathematically how you would get that without taking apart his closet and mixing and matching everything. 1A, the 3 students chosen to represent Mr. Baldrick's class in a school assembly are Adrian, Carlos, and Greg. All 3 of them need to sit in a row on the stage. Use a list to find the sample space for the different ways they can sit in a row. So you could do Adrian in front, Carlos, and Greg. You could do Adrian in front, Greg, and Carlos. You could do Carlos, Adrian, Greg, or Carlos, Greg, Adrian. You could do Greg, Carlos, Adrian, and Greg, Adrian, Carlos. So there are 6 different ways that you could do this. There is a mathematical way to do this, which I guess I'll just teach you. But really what they want you to do is they want you practicing thinking it all through. I'm not going to teach it to you. I'll teach it to you later. I want you to practice for today. I want you to practice writing out all the different ways that they can be combined. 1B, a car can be purchased in blue, silver, red, or purple. It also comes as a convertible or hardtop. Use a table or tree diagram to find the sample space for different styles in which the car can be purchased. So there's lots of different ways that we can go through and figure this out. To me, I think a tree diagram would be easiest on this because you would go blue, silver, red, purple, and I'm going to spread that out. I'm going to start that over actually. You can go blue, silver, red, and purple. And then they each can have a hardtop or a convertible. So you can have hardtop or convertible. Hardtop or convertible. Hardtop with silver or convertible. And hardtop with blue or convertible. So you could have the blue hardtop, blue convertible, silver hardtop, silver convertible, red hardtop, red convertible, or purple hardtop and purple convertible, which means that there are 8 car combinations that you could get. I circle it, and that's my answer. Suppose you toss a quarter, a dime, and a nickel. Find the sample space. What is the probability of getting 3 tails? So, again, I would go with a tree diagram on this one, I think. It just kind of depends. So you have your quarter, and on the quarter you could get a head or a tail. And then you have your dime, and on the dime you could get a head or a tail, and on the tail you could get a head or a tail. So this is saying head on quarter, head on dime, head on quarter, tail on dime, tail on quarter, head on dime, tail on quarter, tail on dime. And then I'm going to go to the nickel, and I could get a head or a tail, head or a tail, head, tail, head, tail. And there are a total of 1, 2, 3, 4, 5, 6, 7, 8 combos that we could get. And it asks, what's the probability of getting 3 tails? Well, there's only one option that's all 3 tails. So it's 1/8. Circle it, and that's our answer. The hardest part will be to get that 8. This is the part that people struggle with the most. So it's thinking through all the options. A lot of people want to take shortcuts and just go, oh, it's 4. Or since there's 3 dimes, or 3 coins, I'm sorry, 3 coins that are being thrown, they'll go, oh, it's 6. They just pick random numbers. You have to think through what are the different options before you can think of how many outcomes there are possible. The school cafeteria gives students 2 choices of snacks, carrots or pretzels. They also offer a beverage of choice of apple juice, low-fat milk, or bottled water. To find the sample space for all possible orders of one snack with one beverage, what is the probability of someone getting pretzels and apple juice? So I've been doing tree diagrams, so I want to do a table for you. So I'm going to make a table, insert here, and we're going to say that there's the snack choice of carrots, and they could get, with carrot, they could get apple juice. I'm just going to say juice. With a carrot, they could get milk. With a carrot, they could get water. With a pretzel, they could get juice. With a pretzel, they could get milk. And with a pretzel, they could get water. So there are 6 different combinations that each of them could get. And it says, what is the probability of someone getting pretzels and apple juice? So that is one option of the 6. So it is 1/6. You circle it, and that's your answer. 3A, to win a carnival prize, you need to choose one of the 3 doors labeled 1 through 3. Then you need to choose a red, yellow, or blue box behind each door. What is the probability that the prize is in the blue or yellow box behind door 2? So we have door 1, door 2, and door 3. And behind each of them, we have a blue or red, yellow, or blue box. They have red, yellow, or blue. So how many options are there? There are 9 total options. And it's saying, what is the probability that the prize is in the blue or yellow behind door 2? So that's 2 of the 9 options. So it's 2 nights. You circle it, and that's your answer.